Hello, welcome to this video on an introduction to integrating VMware CodeStream and HashiCorp Packer. My name's Michael Poor, so let's get started. In this video, I'm going to show you how I've built a CentOS 8 template in vSphere using a public Git repository and an on-premise edition of vRealize Automation 8.1. There are a number of components involved in this deployment. Some of these are hosted out in the public internet, and some of them are held privately in my own data center. The first of these public components is my GitHub repository for my Packer template. The URL for it is shown here. I'll also add it in the video's notes. This repository is completely public to be able to clone from, or fork from, read, that sort of thing. Everything needed to build the Packer template is potentially in there. There's a few caveats to that, but I'll come to it in a minute. The idea behind this is that I very much wanted to have a public repository where I could update it anywhere. I could share it out in videos and as part of my blog. However, I could also get it to trigger builds within my own private data center. So for that reason, I also need a Docker Hub repository that hosts a build image. This is used as part of the pipeline within CodeStream to execute certain commands and functions. And I've built this image specifically so that it contains the most recent version of HashiCorp Packer already embedded into the image. And of course, to build an up-to-date and secure CentOS template, that template, the machine where it's built, is going to need access to the public repositories to update all of the packages that come as part of CentOS that will have been updated in between the time that the ISO image, or the CD image that's used, was produced and the time when I'm actually running this pipeline. In the private data center, we have vRealize Automation 8.1, as I mentioned. There are a number of subcomponents in there: Cloud Assembly, Service Broker, and Orchestrator. Really not the focus of this particular video. CodeStream is the component we'll be focusing on. We also have an instance of GitLab Enterprise. Now this is going to be mirroring my repository from GitHub, and there's a very important reason for this. In order to trigger a build or a pipeline in vRealize Automation when it's in my own data center from an update to the Git repository in GitHub, I have to create a webhook. Now that webhook has to be able to trigger the pipeline execution in VRA. Unfortunately, GitHub doesn't have a route in to my own data center. So I have a GitLab Enterprise instance running in my data center that mirrors the repository from GitHub. Now GitLab also offers the option to trigger an action via a webhook, and that can be triggered from within GitLab Enterprise. Now, if I were using vRealize Automation Cloud, I would potentially be able to use GitHub or even GitLab SaaS offerings to directly integrate with my CodeStream pipeline. But because I'm choosing to do it within my own data center, then I need some sort of mechanism to get from that public repository to my private one or into my data center. Alternatively, I could just host my Packer repository within GitLab Enterprise and do a reverse and actually push changes out into my public GitHub. However, I've chosen to do it this way around because I think it illustrates some important use cases. Another component that we'll need is a Docker host. This Docker host is required to run the Packer build image that we'll pull down from Docker Hub. Now, on that Docker host, I already have a running Nginx container that's running a very simple web server instance hosted on port 80 that's there purely so that my CentOS template has somewhere to get its kickstart configuration file from. Finally, I need a vSphere cluster, somewhere to build the template. Also happens to be the same vSphere cluster where GitLab and vRealize automation and the Docker host are all hosted. But in theory, it could be a completely separate one. Now we're going to move on and have a very quick look at all the bits and pieces and how they hang together. Now, as I mentioned, there are some components that are out on the internet. There are some that are in my data center. We start off with GitHub and my repository on GitHub. When I push a change into GitHub and commit it, that change will eventually be reflected and mirrored back into GitLab Enterprise, which is running in my data center. So GitLab Enterprise will periodically poll or read the repository from GitHub, and it will pick up any changes and mirror them into the local repository in GitLab. Now, when it detects a change, GitLab will trigger a pipeline in VMware Code stream using a webhook. The first task when that pipeline starts to execute is that CodeStream will communicate with the configured Docker host. This could even be a Docker cluster or a Kubernetes cluster, but it's just a single host in my case. But it will communicate with this host and it will trigger it to stand up a container based off the one hosted in my Docker Hub repository. So the Docker host will download the container into the Docker host and it will spin up the container. Now CodeStream will install a process into the container that enables a two-way communication process between CodeStream and the container. And one of the first tasks the container will execute is it will clone the Packer repository from GitLab Enterprise. Once that's completed, there's a process of replacing certain key secure pieces of information, namely the root password for CentOS, the name of the user, the extra user I'm going to create in my CentOS template, and the password for that user. Additionally, for some of my Windows builds, there are license keys that I don't want stored in GitHub. I don't want those available for someone else to pinch. So again, these are things that are replaced in the Packer templates and in the configuration files, the XML, the kickstart files within the Packer container. And then the Packer container uses a shared folder on the Docker host that Nginx can also read to move the necessary files into the correct place. The next step is that the actual Packer process itself starts, and Packer will start off by communicating with vCenter and creating a CentOS VM. Now this is an empty VM at the moment. It will have certain physical resources. It will be connected to a network, it will be placed on a data store, and it will be connected to an ISO image to install CentOS from. Now when the VM is powered on, Packer inserts a boot command into CentOS, into the installer, to tell it where to go and get its kickstart file from. Surprise, surprise, that's from Nginx on our Docker host. So the CentOS VM, using a DHCP address, reaches out to the Docker host or the Nginx, grabs its configuration file, and starts to install CentOS. Once that process is complete, and via vCenter, Packer monitors the CentOS VM to wait for it to obtain an IP address of its own. So once it's gone through a reboot process after the installation, it should pick up another DHCP IP, probably the same one actually. And once Packer realizes through vCenter that CentOS VM has its own IP, it will then start to execute scripts on the CentOS VM. Now, some of the scripts I've got defined, and you could define anything potentially, one of the first ones is to get the CentOS VM to reach out to the CentOS application repositories and update all of the packages on the CentOS VM. So they're all up to date, they're all running the latest versions. There are a number of other scripts that I run to configure things like Cloud Init, to configure the SSHD, to set the message of the day, things like that. There's a number of things that get executed on there. But once these are complete, what Packer will do is it will send a shutdown command to the VM through its SSH connection to it, and it will turn, through vCenter, it will turn that VM into a vSphere template. Now once that's complete, the final task that I have configured in my pipeline is to get CodeStream to trigger an update within VRA to read inventory from vCenter. So it will discover that newly created template, and so it will be available for me to go in and change my image mappings within Cloud Assembly in VRA. And as a final step, once everything's complete, CodeStream releases or destroys the Packer container, and the pipeline is complete. So what we're going to do right now is we're going to go and see this process in action. So here we are in CodeStream. This is the view of all my pipelines. There's a number of them in here that, well, I've been using for development and testing. This one is the one that I will be triggering through Git. Now, the model that we see here shows 3 different phases. There's an initialize phase where I get everything prepared. There's the phase where I actually build the server or the template that's executing Packer, and then there's an update of VRA at the end. So this first task here, as I mentioned earlier, is just to clone the repository. So this takes some inputs from the pipeline, namely the Git repository location and the branch name, and clones it into the Packer container that I've built. The next phase is to go through all of the files that it's downloaded, so the config files and the scripts, and replace certain placeholder texts with passwords, license keys, etc., so that the publicly stored files don't contain any sensitive information. In this create variable phase, we set up all of the inputs that we're going to pass into Packer. So that includes all of the vCenter information and the passwords. All of that is, most of those are stored in variables within CodeStream. I'm just putting them into a single environment variable file that we'll call. Those 2 lines at the top there, Docker host and HTTP IP, those are the lines that I use to determine the IP address of the Docker host. Finally, we copy all of those files that we need, and in this case it's just a kickstart file, into a shared path on the Docker host so that it can be served up by Nginx and available for CentOS as it builds. In this phase, we execute Packer itself. So we are discovering the JSON file in the container that defines the Packer template and running what the instructions that are in there. This final stage, once the template is built, executes a number of REST calls against the VRA host itself. So authenticates against an API token using this particular call here. Once we've got a token back, we extract it out of the response and then trigger a synchronization or an inventory collection of the vCenter endpoint. Now that endpoint ID there is one that you have to supply, you have to discover it, find out what it is. There is a simple postman command you can use, and I'll have to share that later. We then poll VRA periodically, every 60 seconds, to wait for the inventory collection task to finish. It doesn't usually take very long, certainly not in my vCenter. And once it has finished, once the status comes back as finished, that's the end of the pipeline. It's complete. Now the inputs here are automatically added once you select Git as a trigger or an auto parameter injection mechanism for this pipeline. So there are a number of standard things that it creates here. Finally, in the workspace, you see all the details about the Docker host that we're going to use. So I've already created this Docker host as an endpoint. I'm going to tell it which image I want to use. If I had a repository on premise, I could give it that to use, and I can define the CPU and memory limits for the container, how much resource it gets to execute. In this case, 2 CPUs and 1 gig of RAM is perfectly fine to execute Packer. So now that we've looked at the pipeline, let's have a look at some of the endpoints. So here is an endpoint that points at my GitLab Enterprise instance. You can see the repo URL here. It's specifically pointing at the mirrored copy of the Packer CentOS 8 repository, and it's authenticating using a private token that's defined in a variable that's held within CodeStream. Now if we look at Git, we can look at the webhooks that we have available and configured. This webhook is configured against that Packer CentOS 8 repository. So it's configured that when there is a push to that repository, it will trigger the webhook. It will execute that pipeline. Okay, so now that we've seen the webhooks, let's have a look at GitHub. So this is the public GitHub repository for CentOS 8. There's the CentOS8.json, that's the Packer template file. So there's the variables that we pick up from the environment, so we set those earlier on. And in this config folder I have my kickstart file for CentOS 8. So fairly simple CentOS kickstart file. You notice the placeholder here that I'm going to replace later on with a root password that I want to use. So if you have a look, there's this trigger build file that I've put in here. That's what we're going to use to trigger the automatic build. Now in GitLab, in the GitLab Enterprise in my data center, you'll see this particular copy of the repository is mirrored from GitHub. You can see it was last updated 18 minutes ago. So every so often, GitLab will reach out to GitHub and check the status of the repository and mirror any changes. Here we are in Visual Studio Code, so you can see the kind of the clone of the repository that I've got here. So you can see the JSON file and the kickstart config file here with the replace with root password placeholder in there, and all of the other commands that it needs. All of the scripts I'm going to run later as well, they're all in that repository. So what we're going to do now is we're going to update the build file that I indicated earlier, and we're going to update it with today's date. So we're going to save that change in that file on my laptop. And once we've done that, you'll see that source control in Visual Studio Code has picked up the change. So we're just going to commit stage that change and commit it with a trigger build message. And we're going to push the change back into GitHub. So if we have a look at GitHub and refresh this page, you'll see we updated that file 23 seconds ago. Now this change will eventually get reflected in my GitLab Enterprise repository, but as you can see it already pulled 5 minutes ago, so we're going to give it a bit of a kick. If we go into settings, repository and mirroring repositories, we can see the mirroring configuration down here, and it updated 6 minutes ago. And so what we're going to do is we're going to force that update, just because I don't want to wait another 24 minutes or so. As you'll see, it's now picked up that that file has changed. And if we look at CodeStream, the pipeline has been triggered. Now if we look at the execution here, you can see it's preparing the workspace. And what that means is that the Docker host is downloading the container if it hasn't already got it. It's starting the container, and CodeStream is injecting its agent, for want of better words, into that container so that it can execute commands within it. So if we have a look at our Docker host here, you'll see not only the Nginx HTTP server that's running on port 80, but you also see the Packer container that I'm running. And if we look in the shared path here, you'll see there's a folder for the execution number 19, which is the current one, and in there is my kickstart file. And if we just do a little more on it, what you'll notice is the root password placeholder has been updated with my not so very secure password. Looking back at the execution again, you'll see we've gone through all the initialization steps, and we're now executing Packer. So Packer is being called, it's picking up the template file, and it's already created a CentOS 8 virtual machine. And you'll see here in the recent tasks, all of those put USB HID scan code entries, that was Packer setting the boot command for CentOS. In the notes field there, you see all the notes that I want set up, so it's got the version, the ISO it's built from, useful information like that. So we've jumped now onto the console of the VM as CentOS is installing. As I mentioned, it's not a very interesting process to watch. I mean, fascinating once or twice maybe, but you know, once you're into your 10th viewing, it's really not that exciting. So most of CentOS has been installed now according to the kickstart file. It's just finalizing the installation, and then the VM's going to reboot like so. Now we just have to wait a few minutes. We'll just have a look at the log. You can see here on the very last line of the log, Packer is waiting for an IP in the VM. So we just wait for it to start up and get an address from DHCP. Here we are, the VM has started now, CentOS is installed. Let's hop over to vCenter and have a look at it. And if we just wait a second, there we go. It's got an IP address from DHCP. Now Packer will observe this, it will notice this, and it will reach out via SSH to that VM and start to execute some of the scripts that we've defined. They're called post processors. And the first of these is that CentOS is updated. So the VM is now downloading all of the updates it needs from the CentOS repository servers and applying them to get the most up-to-date VM that it can. And now the VM's been shut down, it's been turned into a template, it's Packer's successful basically, and we're into the stage where we're updating VRA. And here you can see that process has completed successfully. VRA has been updated, so it should know about that new template now. And you can see, here we go, it's now a template, it's not a virtual machine anymore. There's a task in there for it to be marked as a virtual machine. Having a quick look back in CodeStream, you can see the pipeline dashboard, and you can see it took approximately 22 minutes for that whole process, from GitLab Enterprise picking up the changed file to the machine being built and changed into a template and VRA being updated. And there you have it. That's the process complete. It took approximately 22 minutes in real time. I did obviously make a few edits during the way, because quite frankly, watching an operating system install once you've done it several hundred times is a bit like watching paint dry, and nobody really wants to do that, do they? So some future changes that I will be making to my pipeline and to my builds coming up include experimenting with the content library integration that HashiCorp introduced into the vSphere ISO builder for Packer 1.6.1. Now, I have tried this out a little bit, and it seems you can only create new catalog library items. You can't update existing ones, and it'd be useful to be able to update them, because the image mappings in VRA can be tied to a catalog library item. So it would actually mean there is less work involved in updating the images that my blueprints or templates in VRA deploy from. So this is certainly something that I will be looking to experiment with and test out as that functionality changes in future versions of Packer. The next thing I should probably do is to deploy and test templates automatically as part of that pipeline process. At the moment, they are built, they are converted templates, and they are left in vCenter. I probably need to do some tidying up as well of older templates, but I do need to incorporate some sort of testing into that pipeline so that I can validate that the cloning of those templates produces a valid machine deployment. The email notifications that I've currently built into that pipeline, I didn't show you those earlier. Those are a little rudimentary and don't contain a lot of useful information. I just wanted to try it out, to be fair. But other notifications could be possible. For example, updating a CMDB or some other system with a notification about the build of the template, or even just notifying someone by email. Okay, I don't want a lot of emails, but it might be nice to know that the pipeline has been executed and something's been built, because ultimately I would like to leave this so that it continually builds whenever I make a change, either in Git or on a schedule, which is a point I'll come to in a minute. Integration with HashiCorp Vault. Now, at the moment, the passwords that I'm using in my templates are not particularly secure. They are stored in variables within CodeStream itself, which most people aren't going to have access to. But because these are static items, every template I build has the same passwords in it, time and again. Now instead, wouldn't it be nice if each time we built a template, it had unique passwords, strong passwords that are secured somewhere, and that's where Vault could fit in. Additionally, the license keys, again, they are a secret. They are a piece of information that you want to keep secret and don't want to let out for all and sundry to use. So again, those license keys could conceivably be pulled from HashiCorp Vault into the pipeline, so nobody needs to know them, nobody needs to see them, and in the case of the passwords, they could be unique for every build. So that reduces the attack surface when templates are being cloned. There's no chance of someone trying the default template password and getting in there before some other process comes in and resets it. Of course, you should still do that anyway, but it just reduces that attack surface. Scheduling regular builds, as I mentioned, is something I want to do. So at the moment, you can't, through VRA, you can't schedule the execution of pipelines. There's a way around it, there's a way to do it, but at the moment you can't schedule that pipeline to run on a regular schedule, and I'd like to be able to do that. And finally, I want to be able to create a catalog item that allows testing of changes before I commit them into my master branch of my GitHub repository. So, for example, I could create a branch of that repository, make some changes, run a catalog item to test them, and see if my changes work within the template that's created before I merge them back into the master branch and produce a gold image effectively. So those are all the changes that I'd like to work on in the future, and hopefully I'll be back to show you some of the updates in a future video and a future blog post. For now though, please do visit my blog and also look me up on Twitter. That's the Twitter account for my blog. My own is @mpor. And I look forward to providing you with a deeper dive into some of the facets of this process in a future video.